Welcome to Status Pro. Today we're going to talk about measuring surfaces in mechanical engineering applications. Typically we occupy ourselves with large objects like machine tools, presses and milling machines. We should start by defining a few terms. For example, what do we mean by flatness? Simply put, the degree of flatness in a surface defines the height of the mountains and the depth of the valleys in that surface. An ideal surface would look something like this. However, nature isn't like that, therefore it looks normally like this. So, as you can see, our surface is not entirely flat, nor is it level. We want to measure where the mountains are and how high are they. The second term we wish to define is level. We describe a surface as level if it is perpendicular to gravity. We could describe a level surface as being in water. Our level surface is parallel to the water level in all planes. If our surface is not entirely flat, then we want to have the average level of that surface in water. Placing the average plane of an otherwise uneven surface in water is what we call leveling. The next issue we want to address is that of accuracy. What accuracy are we looking for, actually? In mechanical engineering applications, we normally are looking for something between tenths of millimeters to micrometers. The following instruments are frequently used for the measurement of flatness: precision spirit levels, interferometers, and precision sweep lasers. However, surprise, surprise, each instrument and method has its advantages and disadvantages. Digital spirit levels, for example, have an excellent local accuracy. However, the basis is very small, typically less than 200 millimeters long. Nothing on this earth measures distance more precisely than an interferometer. However, using this property for the purpose of flatness measurement requires the introduction of additional optical elements like prisms and mirrors. These must be precisely aligned, and that is something which is done better under laboratory conditions. The use of a precision sweep laser for the measurement of flatness in mechanical engineering applications can offer significant advantages. The use of sweep lasers for the measurement of flatness in mechanical engineering applications is not as widespread as the previously mentioned methods, simply because lasers with this precision have not been available for very long. The T330 from Status Pro is probably one of the best examples on the market of a precision sweep laser for mechanical engineering purposes. The flatness measurement package ProLevel uses exactly these characteristics of the T330 for the measurement of flatness in mechanical engineering applications. To demonstrate this package, we need a machine bed, at least a virtual one. There it is. So, where should we start? The first thing to do is to position our sweep laser. For example, here. The T330 generates a reference laser plane by rotating its beam. This reference plane hovers above the surface and is available to us for our measurement. At the push of a button, we can ensure that this reference plane is level and in water. Now I can use this leveled reference plane to measure both the flatness and the level of my surface simultaneously. All we need to do is to measure the distance between the reference plane and the surface at various points to achieve this. We can see the laser beam on the ruler. In this position we read 15.3, and 1 meter further away we read 15.6. Therefore, these 2 points have a height difference of 0.3. In this way, we can repeat this measurement over the surface with many points and then make a comment about both the flatness and the level of the entire surface. Naturally, we require an accuracy which is much higher than that which we can achieve with a ruler. Therefore, we use a laser receiver, in this case the R310. Another convenient advantage of using the receiver is we can zero a point, any point. This point now represents our reference height, and when we move the sensor to another position, for example here, we can immediately read the difference. In this case, we zeroed over there. Now we moved here and measure a distance of 0.53 millimeters. We can repeat this now just as we did with the ruler to measure the surface precisely. A positive reading means the sensor was higher. Therefore, if the points on this side are positive, then the level is tilted like this. Naturally, we are not restricted to distances of 1 meter. We can do the same over 2 meters, 3 meters, 4 meters, 5 meters, 10 meters, 20 meters and more. It is also possible to measure a discontinuous surface. For example, I have one element here, a space, and then another element, or several elements. I can measure my reference point on this surface, and then several other points, and then simply move to the next surface. On the next surface, I simply measure as if both surfaces were connected. Try that with the spirit level. If we now introduce the software ProLevel, which runs on the attached display unit, we can connect the display unit to the receiver per Bluetooth, and then every step we take and every measurement we make is stored and documented in the software. We can define a matrix on the surface we wish to measure, for example 5 by 4 points in this case, and step from one intersection to the next and do our measurement. The matrix and the height of each point in the matrix is then displayed in the software. When we are finished with the measurement, we can then use the software to analyze the measured surface. We have various tools for analysis purposes at our disposal to distinguish, for example, between level and flatness. We can see, for example, if the surface is twisted or if it's bent. We can see what the average flatness is and how level that is. We can naturally produce reports which can be sent by email or printed out or stored in the database. This procedure can be performed very rapidly. It requires minimal training and it offers more than sufficient accuracy for most applications. If this subject is of interest to you and you would like more information or a demonstration, then please contact us at statuspro.com. Thank you.